Nice. Hello, everyone. Camera off. Okay. Hello, everyone. Everyone is dropping in. Okay. And is here. 1, 2, 3, 4, 5, 6, 7. 7 students already online. Very good. How are you today? Good afternoon. Are you tired? I guess so. I am tired. Okay. We start soon. We wait now some 1 minute. Maybe more students come online. Then we start with our lesson about electricity. In our book, I went through the book and I missed something in the book. That is, we have there 2 chapters what we have to study, but there is no basic in there. So for today, I would like to teach you first of all the basic, for you know what is electricity. So I go on the screen share, so you see what I am on it. Okay, I hope you can see my screen. Can everybody hear me? Can you hear me?
Yes.
Okay, because I need to ask, because before I was too loud and I was too silent, and I hope now it is working. Okay, so when we have our reading book in science, there is about static electricity and electrical circles, but what I'm missing here in this book is how electricity really works. What is electricity? And this I am missing in this book because last year we had another book and there was explained what electricity is. So I made a lesson for today so we can understand what is electricity. So now I come first to my PowerPoint. So we have here electricity is something that is all around us. Can you see my monitor? Can you see the PowerPoint? I like only to make sure. Nice. Can you see my PowerPoint? Can you see the picture here? Electricity is something that's all around us. Can you see that? Okay. So electricity is something that is all around us. Raise hands, none pick. Okay. So to understand what is electricity doesn't mean electricity is just in our plug and in our battery. Electricity is always all around us. Electricity means it is a flow of electrons. Electrons flow always. So here's an example we need to understand first where the electrons come from. The electrons come from the atoms. So as example here, you can see here an electron, proton, and neutrons in an atom. In the corner here, you see proton and neutron. And around the atom flow electrons. So we have there positive and negative charged particles. So first we need to understand what is an atom, what is matter. So for this we go through, everybody knows this already. If I put something iron into a plug, I will have a bad surprise. So this is something everybody knows. Electricity comes out from the plug and it's very dangerous. But what is it? So if I put a rubber or a plastic pen or wood in an electrical outlet, it does not shock because we have an insulator. But we have conductors. Conductors are metals, as example, like iron, like copper, like aluminium, like gold, where electrons can flow through the materials. So because these materials already have electrons. So what is matter? Matter is everything around us you can touch or you can feel. Our air, electrons are also in the air. So also everything around us, start from wood, start from the wall, from your house, your body, everything is matter. So this is something what you will learn in next year, in the next years. But we start already in grade 6, the periodic table. Did anyone see the periodic table already? Do you know what is it? Anyone? Does anyone know? Fred, how about you? Did you ever see that? Fred? Everybody quiet. And Sainam, can you hear me? What happened today? Yesterday, everybody so active. How about you, JJ? Can you hear me? JJ? JJ? My microphone is on. JJ, can you hear me? Toto? Hello?
Yes.
Nobody?
Yes.
Can you hear me? I ask questions that
Yes.
nobody
I hear you.
okay, because nobody answer. I ask names and nobody answers, so I'm not sure somebody hear me because the only webcam that is open is from JJ. Everybody else webcam is closed, and if I call a name, nobody answers. So I don't know you hear me or you don't hear me. So okay, so we have the periodic table. Did anyone ever see this? Did you ever see the periodic table before? Otto, how about you? Did you see the periodic table before? The picture what you see now?
Yes, I see.
Okay, so you saw before. The periodic table are all atoms or known atoms, what we know in the nature. So on everything, you must think about Lego. Everything around us is built up with these elements, what we have here. So start from copper, goes over gold, goes over lithium. So here we have as example 118 different elements, different atoms. So we know, now we need to know what is an atom. So what is an element? What does it mean? We can take as example an apple. We cut the apple into 5, 10, 100, 1,000 parts. So we keep on cutting till we come to a point we cannot cut anymore. Same as example here. An apple is made out of carbon, hydrogen, oxygen, calcium, iron, lead. So many different atoms is an apple made out of. So that means everything around us is made out of atoms, of different atoms. So for understand, as example, sugar is a substance, but not an element. It is made out of 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. So if I mix these ingredients together, same you make a cake, you need eggs, you need water, you need baking soda, you need many different ingredients to make something. So here sugar is made out of carbon, hydrogen, and oxygen, and then after I get out sugar. So 12 carbon atoms. Carbon, as example, if you have carbon, pure carbon, we cannot eat it. Hydrogen, you make boom, and oxygen, you anyway breathe. So all together gives sugar, as example. So to understand, you see here, sugar, the chemical receptor of sugar are made out of different type of atoms. Everything you know is made out of 92 elements. We also say we have in all 180 known ingredients. Everything known to us are made out of it. So next we need to understand density. So as example, most of us never had gold in their hands, really big person of gold. So if I have as example, I have gold, everybody know that gold is heavy. And on the other hand, I have aluminium. So the gold is much heavier than the aluminium. This has to do with density because the atoms are more freely as example, in aluminium than in gold. So the density means the weight what the material has. So wood, as example, is not an element, not an atom, but wood has a very low density, very lower density, as example, iron. Iron is much heavier. So we need to know about density. So here's example, we have different atoms, aluminium, iron, copper, gold, and the last one, maybe you know, uranium. Who know uranium? Do you know uranium? Where's uranium used for? Who knows it? Try it again. I must make more open. I have 19 people online, but everybody is quiet. So I'm gonna pick names. Okay, third. I start with third today first. Third. Which element do you know? We know aluminium, we know iron, we know copper, we know gold. Do you know uranium? Anybody know? Hello, we are on Zoom, it's not a video. If a video, nobody need to speak, but we are on Zoom, so we speak also, ladies and gentlemen. If you don't know, you can say, teacher, I don't know. Photo.
Yes.
Do you know what is uranium?
I don't know.
Yeah. Somebody is brave enough to say, I don't know. Okay, very good. Thank you very much, Photo. Uranium you use to make nuclear energy. So as example, a nuclear bomb or in a nuclear plant where we make electricity, they use uranium there. So uranium is something you cannot touch. If you touch it, you are dead. So gold we can touch, there's no problem, copper, iron, aluminium. So when you see as example, here the dots around the material, as gold have a lot of these red dots, copper, iron, and aluminium. So now every element is made out of protons and neutrons. So as example, we have, okay, not every material. So as example, oxygen has only one part. So we have here as example, aluminium is made out of 13 protons and 14 neutrons. Proton, neutron. Everyone know a battery, right? So a battery has positive and negative, plus and minus. It means, as example, in aluminium, I have 13 particles are charged positive and 14 particles are charged negative, protons and neutrons. You must think it's same by boy and girl. The girl like to have a boy, the boy like to have a girl, so they attract each other. They attract each other. So the protons attract the neutrons, so they like to stay together. So same here in the iron, we have protons and neutrons. We have 26 protons and 30 neutrons. Or in gold as example, we have very much. We have 79 protons and 118 neutrons. So the density, here we see the density is here very, very high. The density from 79 protons and 118 neutrons. So this material is very, very heavy. So they attract also a lot of electrons. So we see here the electrons. So the more circles I have around a material, same as example here, I have aluminium, I have 3. Then I have iron, I have 1, 2, 3, 4. And the more I go to gold, gold has example 1, 2, 3, 4, 5, 6 electron circles. So we have here a lot of free electrons. And now we start getting closer. What is electricity? Electricity means come from the word electron. Electricity, electron. It means the flow. Then we have water as example, water flow in a river. But it needs first something for it can flow. By water, as example, we have gravity. Can you remember what is gravity? I ask now someone else. Nana, can you remember the meaning for gravity? What happened today? Nobody answer except both. Except Boto. Boat. Boat, are you there?
Yes.
Yes. Okay, I call it name by name, and then the one would not answer, I know is not there, only then the Zoom is online. Okay. Boat, can you remember what is gravity? Can you remember what is gravity, Boat? Okay, you did not study very much with me the past weeks, so you must know, be smart, say, if you don't know something, say you don't know. If you quiet, I don't know, you know that you don't know. So when you say, teacher, I don't know, I can explain, it's not a problem. Gravity means everything. An example, you take a pen, you leave the pen, it will fall on the floor. Gravity pulls things on the floor by us on Earth and other planets. This is the gravity. In the space, I don't have gravity, so there everything floats. So automatically, the water works with the gravity, so it flows. Number one, when I have gravity, as example, it flows from a mountain to the ocean, or it moves, something moves the water. So the same here is in electricity. The electricity needs a push and a pull for these electrons flow in the material. So it needs a push and a pull. Everything works about a push or a pull, but every pull and push is different. We go one forward. So understand every atom always has the same number of electrons. So not less, not positive, not more, not less. When I give a new electron more to an atom, then another point of the atom lose an electron. So that means electricity means the flow of electrons go through the material. So everybody has a charger cable for your phone. That means from your charger, somebody sent messages. From your charger, flow electricity through the cable into your phone. That means in this cable is copper or another material like aluminum, and on one end that push an electron in, on the other side come an electron out. And this is the flow of electricity. So as example, maybe you know this here. We say there, it's a Newton candle. On one side, I give an electron, and on the other side come an electron out. Very good to see as example. Well, stop again. Okay, here. It's very good to see here. So the electron passed through the material to the other side. So you see it here by these lamps. It gives a push, the electron flies through and come on the other side out. And it push again and come on the outer side. So the material is in the middle, as example, gold or copper or aluminum. And the electrons only pass through the material, but they need a push or a pull. So a push, as example, is in DC electricity. DC electricity is this what you have in your phone. And AC electricity is what you have, as example, in your plugs at home. So DC electricity is in the car, everywhere there are batteries. So there the electrons flow only in one direction. AC electricity is a push and a pull. So electricity, moving of electrons. So we need that to understand as example, when you have a battery, your fan or your microwave, they're everywhere, stay as example, volt, amps, and watt. So we can measure electricity. So as example, the volt tells us how fast are the electrons. The amps tell us how much flow of the electrons. And the watt means the outcoming power. Electron moving, electrons, everything is a little bit a headache to understand because it's very difficult to understand because we cannot see it, we can only feel it. So, but we know that we can't start a car with a small battery. We need a very big battery. We can't charge our phone directly from the plug because this would mean our phone burns up because there comes too much electricity out. So, but why? Too many amps, too many watts, too many volts, and anyway, what the heck is this all? So I don't know what is amp, I don't know what is watt, I don't know what is volt, how we can understand this everything. And so I try to make it easy. You have a pipe. In this pipe, you put balls. So on one side, you push a ball in, on the other side comes a ball out. If you not push a ball in, then on the other side not come a ball out. So this is the meaning how a cable works, how copper works, how conductor works. It must have electrons that goes in, then after electrons come out on the other side. So same as example, you need a cable, you take a cable, you can touch the cable, there is no problem. You can touch the copper, there is no problem. You got not electrons from it. But if you put it as an example in a plug, or you take, please never do that, a screwdriver and put it by plus and minus on a battery, it will have a big effect because then I give flow the flow to electrons. The amps, as example, is the meaning for how much flow do I have. So as example, you see here, everybody know if I have a thick pipe, I have a much bigger flow as I have on a small pipe. So if I have, as example, these two pipes and I open it, then here flow much more electrons than on that side. Doesn't matter, it flows fast and it's slow. So the transfer of energy, so far so good, but how does it work to produce electricity? First, you need to understand transfer of energy. Remember, energy can be transferred into another type of energy, but it cannot be created or destroyed. What does this mean? We don't make electricity. Electricity is already there. So that means we can use the electricity's energy. So we have there, remember, energy can be transferred into another type of energy, but it cannot be created or destroyed. You cannot create electrons. They are already there. But we have to put energy in there to we get electricity out. So as example, chemical energy. So in chemical energy, we use here as example acid and lead in a car battery, or other materials where I can bring electrons to move. You can build our own battery at home with very, very simple products. As example, I show you here a self-made battery. I'll just get it open, just a moment. I built, as example, a battery of myself. Where is it? Where is it? Just a moment. So now, okay. So what I used was charcoal. So we have wood. I burned the wood, so I got coal out, charcoal out. Fire, yes, fire. So, and I used materials you have at home. As example, I used the face mask, I used salt, I used the charcoal, rubber bands, and some aluminium, because I need to get the electron flow out from the material. The next point what I made, I cut, as example, the mask into parts and wrap them around the mask. And I used here another material, copper. So I had here, you need always two different materials. So within here, I had copper and I had aluminium. So I used as example the copper, made it close with the charcoal, and I used on the other side. They cannot connect each other, so you must have a material between this. But still, for the water, the salt water can go through the materials. So we have here these two materials. You see how I made that. After I mixed salt into water and put this together, I rubbed it together. I made a currency measure on there, and I put it into the salt water. And after, what happened is I got out currency. So same here, you see there, the currency flow from the copper to the aluminium was 0.75 volt. It means nearly 1 volt. It's not much, but you see the flow of electrons from the copper to the aluminium. What I used here, the charcoal and the salt solution. So electricity is everywhere around us, but we must make something to be get it flow. So here's an example of a battery. Okay. So chemical energy means it flows from one side to another side. So as example, we have here on one side a different material than to other side. So the electrons flow from one side to another side. So as example here, you see here after a time, the material flows, the electrons flows from one material to another material. The same when you have a car battery, after 2 years, after 3 years, you can throw away the car battery because it is used up. So the lead in the battery is used up. So chemical energy works the same way. Also means electrons flow from one material to another material. Or you have, as example, you have a nuclear plant. How does a nuclear plant work? Who know how does it work? Anyone know? If you know how does it work? A nuclear plant works in the way of mechanical energy. Mechanical energy. So nuclear plant works as it's there. Imagine you heat up water to a very high degree, you get steam. So we use as example uranium, the split of uranium. What is the atom energy, the nuclear energy, to heat up water to a very high degree and make steam out of that. These steams flow into a turbine and produce the energy. So that means mechanical energy goes into electrical energy. So when we have here as example in the nuclear plant, we can see that mechanic to electrical energy. So we have here the center of a nuclear plant with uranium and here flow of water. So you must imagine nuclear plant, how energy works, the heat core of a nuclear plant, uranium, and come here. How does it work? So it has to do with splitting atoms, but we not learn now about nuclear energy. We learn about electricity. So we go here through nuclear fusion produce the heat that is 10 times hotter than the sun. So we have here as example 150 million degrees. So you must imagine in the nuclear plant, the heat what the uranium produce is 10 times hotter than our sun. So it needs to be cooled with water. So we use the water on one side to cool and use the water as energy because nuclear, the uranium heats up the water to a very high degrees, and there we use the steam as mechanical energy on turbines. So we have here the flow. This is mechanical energy. So mechanical energy means something like water, like steam moves. Then here it goes into a turbine, and the turbine generates energy in the generator, and so is the way how we produce electricity. Mechanical energy goes into electrical energy, means a movement of electrons in a motor. Here you can see a nuclear plant turbine. So the turbine here are very huge. So I have here nothing to compare. You can see the screws here around. The turbines here are at least 20 meters, 30 meters long, where flow the hot steam through And here we say again mechanical energy. So this turbine gives the mechanical energy into a generator where we produce electrical energy. Here you see a nuclear plant where you see many turbines in there. So you see in yellow are the turbines, and in blue are the generators where we produce electricity. How do you think about this picture? Did you? Fred, are you there? I feel like I talk with myself today. Both have been answering before. Nampet, are you there? Peppa Pig, who's that? Ladies and gentlemen,
Yes.
wow. I feel like on the graveyard. I must tell it. I need to tell it. It's only both to say something, and I have 19 other students online, and everybody is quiet. I can call names, and everybody is quiet somehow. Ferd is quiet today. Saina not say something. Nana is quiet. Why we are so quiet today? Why is everybody so quiet? Are you so tired today? Fred, how about you? I see your microphone goes on, but I not hear anything. Sainam, are you there?
Yeah.
Oh, thank you very much. Okay. Fred, nice. Mac, are you there?
Yes.
Yeah. The point is, I can just produce videos. You understand? You don't understand. Who cares? I care. For this I Zoom. But we need communication. We need talking like, hey teacher, I don't understand it. What is the meaning of flow? What is the meaning of electricity? What is the meaning of electrons? I don't understand. So when you don't understand and not talk anything, I go through the lesson like it is a video. And this is something I don't like. So I not like go through the lesson like a video because there is no response system like the same as YouTube. So this is the reason I go on Zoom for we can talk with each other. So you can ask questions. So I need a little bit of response from your side too. Okay. Let's see what did you understand? I'm not gonna ask now Photo because Photo is still now the only one who talks. Both, are you there? Both is good at English?
Yes.
Yes. So when you hear where come electrons from? Did you understand where the electron come from? Electron, electricity, where it come from? Did you understand that? เข้าใจหรือไม่เข้าใจ Quiet again. Yes. Who say yes? So it's not very helpful if nobody talks. Okay. Make me. And how about you? Quiet. Who can tell me where is the electron from? Where is the electron from? Who can tell me? Hmm? Who can tell me? Where's the electron from?